Hello, this is Mr. Collier.
And hello, this is Mr. Gray.
And today we're doing inverse trig derivatives, okay? First, we have an unrelated starter. This is a review of something we did earlier in the year. So recall first, you can write this as 1 plus 2x to the power of half. And then we can use this, this rule that we learned earlier in the year. So 1 plus 2x squared to the power of half. So in this equation, the alpha will be the exponent, which is half, and the x in the equation is going to be 2x squared. Okay, so we start off with 1. That's pretty easy. That's always the first term. Plus alpha x, so that's half times 2x squared. And then next we're going to have alpha times alpha minus 1 times 1 over 2 factorial times x squared, which is actually 4x to the power of 4. And they don't tell you how many terms there are, but I'm going to do one more. Okay, so we have alpha times alpha minus 1 times alpha minus 2 times 1 over 3 factorial times 2x squared cubed, which is 8x to the power of 6. So that simplifies to 1 plus x squared minus, now the 4 cancels with these two 2's, so it's minus half x to the power of 4. And over here we're going to have plus, these 2's cancel this 8, 3 cancels with 3 there, and we have just 2 factorial left, so it is half x to the power of 6. Okay, next we're going to look at some inverse trig functions, and they're very easy to derive the formulas for these. The formulas for all three of these are in the formula booklet. Okay, but they're easy to derive if we draw a triangle. Okay, so if we have y equals arc cosine x, and that's the same as cosine y equals x. So y is an angle, and if cosine equals x, that's adjacent over hypotenuse. So the opposite side is, by Pythagorean theorem, 1 minus root 1 minus x squared. So then we can figure everything out from this triangle. So we have this equation here. We can differentiate and do implicit differentiation. So the derivative of cosine is negative sine. And then we got to use chain rule and multiply by y prime, which is basically dy dx, equals 1. And then we have y prime, which is dy dx, equals negative 1 over sine y. But if we look at the diagram, sine y is opposite over adjacent, or opposite over hypotenuse, which is just root 1 minus x squared. Okay, and this matches the formula in the formula booklet. So if you do the same thing with the triangles, you'll get the formula for arc sine is 1 over 1 minus root, and we have that, and then this here is going to be equal to 1 over 1 plus x squared. Okay, derived similarly with some right triangles. Okay, we're going to go over a couple examples, not all of them. You could do some of them yourselves. Let's do this one first. Okay, so the derivative of arctan is 1 over 1 plus x squared. So it's going to be 1 over 1 plus, now the x in this case is this whole function x squared plus 2, right? But you always got to remember to use the chain rule, so we don't have just x in here. We have x squared plus 2, so we have to do the derivative of x squared plus 2, which is 2x. Okay, so your answer is 2x. I'm not going to bother to simplify this time because there's no need to. I'll just leave it like that. Okay, we're going to do number 2. Find the gradient of the curve when x equals 1/3. So we'll find the derivative first. So the derivative of cosine, or arc cosine, is negative 1 over root 1 minus x over 2 squared times the derivative of what's inside the brackets by chain rule is half. Okay, so that's equal to negative 1 over 2 root 1 minus x over 2 squared. You could even simplify a bit more because 2 equals root 4, so you can multiply by 4 everything inside here. So it's 1 over root 4 minus, that 4 cancels with this 4. That's going to be 4 minus x squared. Okay, find the gradient when x equals 1/3. We just plug in x equals 1/3. So the gradient is negative 1 over root 4 minus 1/3 squared. And let's simplify that. Negative 1 over root 4 minus 1/9, which equals negative 1 over root, that's going to be 36 over 9. 36 minus that is 35 over 9. But you can square root 9 is 3. So 1 over root 35 over 3 is going to be 3 over root. So we're going to check our answer using wolf from alpha. You can type in the word derivative. It's very easy to use. Derivative of, and then your function is arc cosine x over 2. And then you can even say at x equals 1/3. And it'll do the calculation for you. Okay, it'll give you all kinds of information. There's the answer. Negative 3 over root 35. Okay. Next, we're going to do this example, and we're going to have to use implicit differentiation. Okay, and on the left, we have a product of two functions, so we're going to use product rule. So the derivative of x is just 1. And then the derivative of arctan y is going to be 1 over 1 plus y squared. But by chain rule, we do dy dx as well. Okay, equals 0. And if you want to solve for dy dx, well, we have x over 1 plus y squared dy dx equals arc negative arc tan y. So dy by dx equals negative arc tan y times 1 plus y squared over x is the final answer. Okay, we're going to go over maybe one of these, just the first one, I believe. Okay, let's do this one. So dy dx equals arc sine is, now we got a 2 here. So we're going to have 2 over root 1 minus 2x minus 1 all squared. Times, by chain rule, we do the derivative of what's inside the brackets, which is 2. So it's going to be 4 over. It's going to be root 1 minus, this is going to be 4x squared minus 4x plus 1. Okay, and it simplifies a little bit because we have 4 over root, the 1's cancel. We get... Actually, we get 4x minus 4x squared. And we can factor out a 4. Square root of 4 is 2. So it's going to be 4 over 2 root x minus x squared, which equals 2 over root x minus x squared. Okay, and you can try this other one yourself. Okay, next we're going to do this one. It's got an arc sine instead of a sine. Okay, so let's start differentiating. Actually, I think I need more room, so I'm going to go over here. So y prime of t equals, derivative of sine is cosine. So we have cosine arc cosine t times, by chain rule, the derivative of what's inside the brackets, which is negative 1 over 1 minus t squared, root of 1 minus t squared. Now cosine of arc and cosine, they just cancel each other out. So it's negative t over root 1 minus t squared is the answer. Okay, next we're going to do this one. Now again, looks like a product rule here. So let's differentiate. We got dy dx equals derivative of x is 1, so 1 times arc cosine x plus derivative of arc cosine is negative 1 over root 1 minus x squared. Now this is, recall, this is 1 minus x squared to the power of half. So when I differentiate, I'm going to have half times 1 minus x squared to the power negative half. And by chain rule, I'm going to multiply by the derivative of what's inside the brackets. So that's times 2x. Okay, let's start simplifying. We have arc cosine x. This is minus x over root 1 minus x squared. And this is going to be, now this should be negative, did I write negative? Because the derivative of negative x squared is negative 2x. So negative times negative is positive. 2 times half cancels. So we just have x. And then this is root 1 minus x squared in the denominator. So you see these two terms actually cancel. So we have arc cosine of x is the final answer.